Today we are taking notes on section 5.6, which is the quadratic formula. First, look at the different ways that we have solved quadratics so far. We've graphed quadratics. We graphed them on the graphing calculator and found where the quadratic crossed the x-axis. We've factored. We've done the square root method. So this is what we did with the imaginary solutions when you moved the numbers over to one side and then took the square root. Today we're doing the quadratic formula. Okay, so before we write down the formula, I want to talk about when to use the quadratic formula. Quadratic formula is generally used for non-factorable or prime quadratics. So you should always check to see if the equation is factorable. If it's factorable, factor it. If it's prime, so you can't factor, use the quadratic formula. Quadratic formula is x equals, now you probably learned a little song about this. Sorry, I don't have the best singing voice. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have two examples and then we're going to talk about the discriminant. Here's our first example. In front of the x squared is the a, in front of the x is the b, constant at the end is the c. I'm going to write down the equation. You should always write this down first before substituting numbers in. Okay, if our b is 8, the opposite of b is negative 8, plus or minus 8 squared, subtract 4, a is 2, c is negative 5. All over 2, and then a is 2 again. I'm going to start by simplifying what's under the square root. So 8 squared is 64. 4 multiplied by 2 is 8. 8 multiplied by 5 is 40. Here's the tricky part, is it becomes a positive 40. That's because we have a negative 4 and a negative 5. Negative multiplied by a negative is a positive. And everything's divisible by 4. Okay, 64 add 40 is 104. Okay, now don't just start dividing everything by 4. We have to simplify that square root of 104 first. So I'm going to do that over here. 104 is even, so I would try dividing it by 4 since 4 is a perfect square. 4 multiplied by 25 is 100. Therefore, 4 multiplied by 26 is 104. Square root of 4 is 2, and then root 26 does not simplify anymore. So now we have negative 8 plus or minus 2 root 26 all over 4. We have one last step to simplify. I need to find the common factors of 8, 2, and 4. Largest common factor, the greatest common factor is 2, so divide everything by 2. That leaves us with negative 4 plus or minus 1 root 26 all over 2. You do not have to write that 1 if you do not want to. There are two solutions here. The negative 4 plus root 26 over 2, and then the negative 4 subtract root 26 all over 2. So there are in reality two solutions. Okay, one more that we're going to do together. Here's the second example. First thing that we need to do is move that 7x over. Everything has to be set equal to 0. So that's x squared, add 7x, add 20 is equal to 0. Now, our a is 1, our b is 7, and our c is 20. Again, I'm going to write the blank formula. And then we're going to start substituting. B is 7, so the opposite of b is negative 7, plus or minus the square root. 7 squared, subtract 4. A is 1, c is 20. And all over 2a. Again, start by simplifying the square root. So that's 49, subtract 80, all over 2. I'm going to continue up here. 49 subtract 80 is negative 31. Okay, now because we have this negative under the square root right here, we're going to have imaginary solutions. Remember that we don't leave the negative under the square root. That negative under the square root becomes an I. And then we still have root 31 all over 2. Can't simplify the square root of 31 at all, and there's no common factors of negative 7i and 2. So here are our 2 imaginary solutions. Okay, now we're going to talk about the discriminant. The discriminant is that part underneath the square root, the b squared minus 4ac. The discriminant will tell us the type of solutions and the number of solutions that a quadratic equation has. So if you would please draw this table. I'm going to rewrite the quadratic formula over here. Okay, so this part in red is the discriminant. So your discriminant can be positive. There are 2 boxes for positive, and we'll talk about that in a minute. It can be negative, or it can be 0. Okay, so negative is the case that we just did. If your discriminant is negative, you're taking the square root of a negative number. That will give you 2 imaginary solutions. You get 2 imaginary solutions when your quadratic equation does not cross the x-axis. So an example would be something like this. Does not cross the x-axis, so we're going to have 2 imaginary solutions. If your discriminant is 0, then you're going to have negative b plus or minus the square root of 0 all over 2a. Negative b plus 0, negative b minus 0, that's just negative b. So you're going to have 1 rational solution. Just remember that rational means the solution can be made into a fraction. So like 7 over 4, 2, negative 3, but you're not going to have square roots, like square root of 7 or square root of 5. This will happen when you have a double root. So an example like that would be one here. There's only one solution, and that solution is right here. Okay, for positive, the discriminant is either a perfect square or it's not a perfect square. If the discriminant is a perfect square, you will have 2 rational solutions. So again, that just means fraction, but not a not perfect square root. So, example of these is if your discriminant was 4, 16, 9. If your discriminant is not a perfect square, it's 17, 18, 24. You're going to have 2 irrational solutions. So those are going to be square roots that you cannot simplify. Same picture for both of these. Okay, because we have 2 real solutions, rational and irrational are real numbers, your quadratic is going to cross the x-axis twice. Here's one solution, here's the other one. So we have one example to do for discriminant, and then you have 2 to do on your own. Here's the example that we're going to do together. It says find the discriminant and then describe the number and type of roots. So the discriminant is b squared minus 4ac. Here's our a, here is our b, here is our c. So that ends up being negative 11 squared, subtract 4, multiplied by 7, multiplied by 5. Negative 11 squared is 121. 4 multiplied by 7 is 28. So we have 121 subtract 140. 28 multiplied by 5 is 140. This ends up being negative 19. because we're taking the square root of a negative, we're going to have two imaginary solutions. You don't actually have to find them, you just have to be able to describe to me what they are. Here are the two examples I would like you to do. Pause the video right now, do the quadratic formula on the first one, and then use the discriminant on the second one. Welcome back, we're going to do these two together. I expect that you already tried both of them. You should have gotten negative b plus or minus the square root of b squared subtract 4ac all over 2a. This simplifies to be negative 5 plus or minus the square root of 9 all over 2. Do not leave your answer like this. The square root of 9 we already know is 3. Don't leave it like this. You can still simplify. This becomes negative 5 plus 3 over 2 and negative 5 minus 3 over 2. Negative 5 plus 3 is negative 2. Divided by 2 is negative 1. This becomes negative 8 over 2, which is negative 4. So your two solutions are negative 1 comma 0, negative 4 comma 0. And this polynomial was factorable, so we could have factored. Second one, first thing I would have done is rewrite the order. Okay, discriminant is b squared subtract 4ac. That's negative 7 squared subtract 4 multiplied by 10 multiplied by negative 4. This becomes 49. Add 160, which is 209. 209 is not a perfect square, so we're going to have two irrational solutions. So they're going to be real numbers, but you're going to have a square root that you can't simplify. Hope those went well for you. Quick look back at the different solving methods you now have. You can now graph, factor, take the square root, or use the quadratic formula. You need to know how to use all four. Sometimes we'll tell you a specific method to use, and then sometimes you'll be allowed to choose.